Here I wanted to try out a couple more examples of the inside-out approach to taking derivatives using the chain rule. So here are the rules that I had in mind for us today, the functions that I had in mind for us today. Here we have f of x is equal to the secant of the square root of x. This is simply one composition of functions, so we will let u be equal to our inside function, which is in this case the square root of x. In anticipation of what we're about to be doing, we'll refer to that as x to the 1/2 power. That way over here we can express this function as f of u is simply equal to the secant of u. Now if we're interested in taking the derivative f prime of x, this would be equal to f prime of u, that is the derivative of the secant function of u with respect to u, times du over dx. Now the derivative of the secant function is the secant times the tangent, and the u will stay the same in both of those cases. Then we'll also include the derivative of x to the 1/2 power, which will be 1/2 times x to the negative 1/2 power. Substituting back and reordering a little bit, this will be equal to, this expression here can become 1 over 2 square roots of x. The x to the negative 1/2 power, negative means denominator, 1/2 means square root. And this will be times the secant of, we'll substitute back and call that the square root of x, times the tangent of the square root of x. And that'll do it for that one. For our next function, f of x is equal to x squared times e to the negative 2x power. Big difference that we have here in comparison to some other problems is that we are going to have to use the product rule as well. So I wanted to do a quick substitution over here for when we get to it. Let's bring in y equals e to the negative 2x and observe that this is in fact a composition of two functions, our inside function being negative 2x. So the derivative of that function is going to wind up being negative 2. So the derivative of y with respect to u would be the derivative with respect to u of e to the u, which thankfully is just still e to the u. So combining these together, we're going to get that this derivative is equal to negative 2 times e to the negative 2x. In fact, more generally, when we're taking the derivative of a composition of two things and the inside function is linear, then the chain rule is going to contribute the slope of whatever that linear function was. So, combining that with the product rule over here, this will be f prime of x is equal to the first times the derivative of the second, plus the second times the derivative of the first. Now for the first portion, x squared times this derivative is what we did over here. That'll be negative 2 e to the negative 2x plus e to the negative 2x times the derivative of x squared, and that would be 2x. Now what you could do with this is factor out a common factor. Both of these terms have a 2x e to the negative 2x in common. If we factor that from the first term, that'll take away the 2, the e to the negative 2x and one of the x's. We'll be left with negative x. Do that on this term and we'll be left with simply 1. So final answer for this one, 2x e to the negative 2x times the quantity negative x plus 1. And for our third installment of the inside-out approach to the chain rule, here we have f of x is equal to x squared over x plus 1 all raised to the third power. Our inside function in this case being u is equal to x squared over x plus 1. In order to take this derivative, we will need to make use of the quotient rule. Quotient rule says low, d high, less high, d low, over the square of what's below. So I took the liberty of taking those two derivatives since they are relatively straightforward. Distributing will give us 2x squared plus 2x minus x squared all over x plus 1, quantity squared. Or simplifying further, this will be x squared plus 2x all over x plus 1, quantity squared. Comparing that to this over here, f of u at this point would simply be u cubed. Therefore, the derivative with respect to u of f of u is going to be 3 times u squared. Therefore, if we're interested in finding f prime of x, that will involve taking this derivative times this derivative. X squared plus 2x all over x plus 1 quantity squared. Substituting back gives us 3 times x squared over x plus 1 quantity squared times x squared plus 2x all over x plus 1 quantity squared. If you wanted to, you could probably even combine this into one single fraction with a numerator of 3 times x to the 4th times x squared plus 2x all over the denominators combined. So this would be x plus 1 squared times x plus 1 squared. That would be x plus 1 raised to the 4th power. There's probably a way to simplify that further, but I'm not going to bother. So we'll just leave it as is.